Hi everyone, in this video I show you some important information about the distinction between power functions and variations. So the general form of power functions is that the function term is given by some a times x to the nth power plus b. And a power function is called a variation if the b equals 0, so if it's just a times x to the power n. We said already that if n is so, in the variations we can distinguish between direct variations and that's the case if the n is positive, and inverse variations if the n is negative. So for instance, an example would be f of x equals 8 times x to the third power. This would be a direct variation of degree 3, so we call this n the degree of the function or of the variation. And in this case we would also say that the new variable, so the y variable, is proportional, or it varies directly with the third power of x. So we could state this like this: y varies directly with x to the third power. So this symbol means that something is proportional to each other. It's similar to an alpha, but it's not an alpha. It means that y is proportional to the cube of x. An inverse variation could, for instance, be this one: f of x equals 15 times x to the negative 2. By the way, you could also write this as 15 divided by x squared. Remember that x to the negative 2 means 1 divided by x to the second power, so it's 15 over x squared. And you would tell this in a way that y is proportional to 1 over x squared. So if you use this proportional sign, then you would only state the variables but not the constants. So 8 or 15, they would be called the proportionality constants, the constants of proportionality. In a direct or an inverse variation. Okay, and the power function in general would also allow a plus b. What does this plus b do? So if a variation, for instance, a variation could be, let's draw the 8 times x to the third power. If a variation function with power 3 looks always something like this. And if we add a b, so if we use, let me use a different color. We use, for instance, f of x equals 8 times x cubed plus 3. Then this plus 3 would mean that we shift all of the function graph by 3 units upwards. So if you take every point on the function graph and lift it upwards by 3 units, then you would end up with something like this. This would be the new function graph of this power function 8 times x cubed plus 3. This is not a variation again, because a variation always needs this b to be 0 so that it goes through the point 0, 0 if it's a direct variation. And this new power function, of course, it doesn't pass through the origin, but it passes through the point 0, 3 in this case, because the plus 3 makes it cross the y-axis at 3. Okay, there is a systematic property of the power function, of the power functions in general, because their general shape depends on the n. So if, for instance, we have x to the second power, or x to the fourth, or x to the sixth power, then the graphs will always look like this. Of course, some variation between x to the second and x to the fourth, that's clear, but in general they would always look like this. On the other hand, if you have x to the power 3 or 5 or 7 and so on, they would always look like this. So these even powers, these even exponents, they generate a kind of a generalized parabola, and the odd exponents, they generate an S-like shape. What would happen to negative powers? The negative powers, for instance, x to the negative 1, x to the negative 3, x to the negative 5, 7, and so on, they would look like this. So there would be an inverse variation on this side of the graph, and the same thing reflected downwards, so it would look like this in the negative region. While if the exponents are even and negative, in this case it would look like this. This part would be quite similar, but this part would be different because it would be here. So these are the four general shapes of power functions. So the negative shapes, they are called hyperbolic shapes. This one would be a parabolic shape, and this one would be an S shape. Okay, there is of course the possibility to include some variation in the parameters. So for instance, if you have x to let's assume x to the power 4, that would look a bit like this. And if you now add a 3 times x to the power of 4, the result would be that this shape stays the same, but it's getting steeper. So for instance, it could look like this. On the other hand, if you used a factor like 0.5 times x to the 4th power, then you would end up with a shape which is less steep. And there's also the possibility to invert it completely, because if you use a negative number for this parameter a, then for instance if you use minus negative 2 times x to the power 4, then you would invert the whole graph on the x-axis, and it would look like this. So this parameter a, in this case we would have 1 for a. This parameter a means that if a is more than 1, then it's getting steeper. If a is between 0 and 1, then it's less steep. And if a is negative, then it's bending downwards, it's inverted at the x-axis. So this is the meaning of the parameter A. The meaning of the parameter B, we discussed it. It means just a shift upwards or downwards. And the meaning of the parameter n, the exponent, the degree of the power function, this controls the general shape. So we could create a parabolic shape, an S shape, or a hyperbolic shape with even or odd degree. So this is the general system of power functions.